In this video, I'm going to explain to you the difference between an enlargement and a reduction based on the transformation of a dilation. We'll discuss how the scale factor or the ratio of the side lengths is proportional between the two similar figures. And then I will show you two ways in which you can determine the dilation and or scale factor of the figure after the dilation has been completed. So a dilation, if you remember, earlier in the year we talked about three types of transformations: a rotation, a reflection, and a translation, all of which did not change the size or shape of the figure. Okay, a dilation actually is the only transformation that either enlarges, and to enlarge means to make bigger, or to reduce, of course, which is to make smaller. And anytime we enlarge or reduce a figure, the side lengths change, but the angles remain congruent. So a scale factor, or the ratio between the sides, tells us whether the figure is an enlargement or a reduction, and also what value that scale factor is. So how much bigger did the figure become, or how much smaller did the figure become? So let's look at this first example here. It says determine whether dilation from triangle ABC to triangle DEF is an enlargement or a reduction. Then find the scale factor of the dilation. Now, notice how it says from ABC to DEF. Okay, so this tells me that ABC is the original triangle, and DEF is the enlargement or reduction after the dilation has been completed or performed. Okay, so if we look at ABC is my blue triangle, and DEF is my green triangle. And as you can see, going from ABC to DEF, I get a smaller triangle than the one I originally started with. So DEF is smaller than ABC. Therefore, it is a reduction. Okay, fairly simple. Now, it also says to find the scale factor. Okay, so to determine the scale factor, we're going to write, remember, scale factors can be written with a colon, such as 2 to 3, or it can be written as a fraction, 2 to 3. Now, these are just examples of scale factors or ratios. These are just examples. Okay, so how do I determine the scale factor for ABC and DEF? Well, I'm going to write the fractions such that the triangle DEF, or the dilated figure, is in the numerator, and the original is in the denominator. Okay, so here we have only a single set of values. So we know that DE is the figure after the transformation or after the dilation. AB is the original. So plug in my values for DE, which is 2, AB is 6. So when I reduce, just like slope, we have to reduce our scale factors to simplest form. And both 2 and 6 are divisible by 2, giving me a scale factor of 1/3, or if I was to write it was a ratio, 1:3. Now, if the problem was reversed, if we go back to our original problem, this was a reduction going from a large triangle to a small triangle. And here my scale factor is 1/3. It is a fraction. Fractions are smaller. Now to confirm that I determined this scale factor correctly, I'm sure some of you would see, oh, well, 6 divided by 3 is 2, which is correct. But when we are performing a dilation, and we will get to that in another video, we actually always multiply. And I'm sure some of you are like, well, how do you multiply? It's getting smaller. But if I multiply by 1/3, remember I can put a 1 over a whole number to multiply straight across. What I get is 6/3, and 6 divided by 3 is 2. So even though I'm technically multiplying by a fraction, when we simplify, we do actually divide. So I know it's very easy to assume that when we're reducing, when the dilation is a reduction, that we're dividing. And that is true to a point. But on a test, it's going to ask you, it's going to ask you what the scale factor is. And if you say 3, unfortunately that would be incorrect, because we have to differentiate between the fact that it's getting smaller and multiplying by 1/3. A lot of information in a little bit of time, but we're going to see some more examples, so hopefully it will make a little bit more sense when we put this back together. And this is, it says here, note the order of the similarity statement as follows. And that's basically exactly what I just went over. So we're here, the reduction ABC to DEF was 2/6 or 1/3, whereas DEF to ABC, where it gets bigger, is 3/1, which we know we can simplify as 3. All right, let's take a look at what if it was DEF to ABC. Okay. So the question would read, from DEF to ABC. So the question, the order of the figures and how they're named in the question is important. So again, to find the ratio, it's the image over the original, image being the final size of the figure after the transformation. In this case, if we're going from DEF to ABC, then AB would be in the numerator and DE would be in the denominator, giving me a reversal of, instead of 2 over 6, I have 6 over 2. And 6 divided by 2 is 3, or as we can say, 3 to 1. And that makes sense because I'm going from a smaller triangle to a larger triangle. So obviously this is an enlargement. And my scale factor is 3. It's a whole number. And I can verify that I divided correctly simply by saying, okay, if I take 2 times 3, I get 6. So the triangle ABC is 3 times the size of triangle DEF. Okay? Versus multiplying by 3 to a whole number to get an enlargement. Okay, I know there's an actual example here and what that looks like. Now, most dilations or enlargements are done on a coordinate plane. The example we just did exactly was just for definition vocabulary purposes. So here we have, you can see, I have triangle RST, and notice how that's my black triangle. And then I have my red triangle, which is R prime, S prime, T prime. Okay, remember, when the prime triangle is the image or the figure after the dilation or after the transformation. The ones without the prime or the apostrophe is always our original figure. So you can see here that my original figure is smaller than triangle R prime S prime T prime. So the fact that it got bigger tells me that it is an enlargement. And we can ask the question, is my image or triangle R prime S prime T prime an enlargement or a reduction when compared to my original? Obviously, it is bigger, so it is an enlargement. Now, to determine the scale factor, or how much the dilation is, or how much, in this case, how much bigger my triangle is, we can compare the side lengths. Okay, so let's take a look at, we're going to count the length of RT from my original. So this is 1, 2, 3, 4, 5, 6. It has a length of 6 units. And then I can count R prime T prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. says here, since the scale factor needs to be the same for all three sides to do a true dilation, we only need to count one set of side lengths. Now, I could have counted RS to and compared it to R prime S prime, which I could do to show you that it's the same length, but you only have to choose one pair. Okay, now the scale factor, again, we're going to write it as a fraction with the image, or the R prime T prime, in the numerator, and the original in the denominator. And when I simplify this, 18 divided by 6 is 3. So I have a scale factor of 3 to 1, or if we were to write it with a colon, we'd write it as 3 colon 1. And that makes sense because my first side RT has a length of 6, and when I multiply that times 3, I do get 18. So that's that scale factor. It's that number that I'm multiplying my original side length to get my dilation. Now, another way that we can solve this exact same problem is using the coordinates. Okay, so same problem. We already know that this is 6, has a length of 6, and this has a length of 18. But we're going to look specifically at and compare the original coordinates of RST and compare them to my final image of R prime, S prime, T prime. So if you can see here, we have R and R prime, S prime, T, and T prime. And as we mentioned, the scale factor is the number that is multiplied by to get the final coordinate. And that works for both the side length and the coordinates we're looking at. Same concept. When we looked at the lengths, we saw it's 6 times 3. That gives me 18. So that's my scale factor of 3. So we can look at the coordinates as well and ask the question, okay, what number times -2 gives me -6? And when we look at the y coordinate, what number times +2 gives me +6? Now, as we've already determined, if I multiply both my x value and my y value by 3, I get the final coordinate of R prime, because -2 times 3 is -6, and then 2 times 3 is 6. Okay. And I can do this for coordinates S and T as well. So here, S, we have -2. Okay, what can I multiply -2 by to get -6? Well, we just figured that out when using point R. It's obviously 3. And then for my y coordinate, -4, what times -4 gives me -12? Oh, that happens to be 3. -4 times 3 gives me -12. And lastly, we have T. We have 4. What times 4 gives me 12? Obviously, that is 3. And what times 2 gives me 6, which is 3. So what is my scale factor? My scale factor is 3. So we can use either the side lengths from the graph, as we did here, or the coordinates either option will give us the scale factor. Let's take a look at another example. Okay, here, remember, triangle ABC is our original, and then triangle A prime, B prime, C prime is my image. After the scale factor has been applied and the dilation is complete. So you can see here we have triangle ABC is larger than my image. So that means what I have is a reduction. Okay, so to determine how much the dilation is bigger or smaller, we can compare the side lengths. And we only have to do it with one set of sides. So go ahead and count the length of AB, count the length of A prime, B prime, and see if you can determine, what do you notice about those side lengths? Okay, so AB is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, AB has a length of 10. A prime B prime is 1, 2, 3, 4, 5. It has a length of 5. So I have AB is 10. A prime B prime is 5. And I hope that some of you recognize that, oh, 5 is half of 10. Or 2 times 5 gives me 10. But because we have a reduction, our scale factor is going to be a fraction. The only way we can get a figure smaller is if we multiply by a fraction. So you notice, remember, the value of the image always goes on top. The original is on the bottom. And when I reduce or divide both numerator and denominator by 5, I get 1/2. So remember, yes, we divided by 2. We do 10 divided by 2 to get 5. But dividing, the way we can mathematically show or demonstrate that we divided by 2, we write the scale factor as a fraction. Okay, now let's look at the same example, looking at the coordinates. Okay, so same example, I got ABC is reduced to A prime, B prime, C prime. So let's compare our coordinates. -6 to -3, 4 to 2, -2 to -1. And again, we always have to, it's always multiplying. So anytime we have a reduction, we know that this is divisible, we're dividing by 2. But remember, we can rewrite that as multiplying by 1/2. Because when I multiply -6, I can put that over 1, and I multiply that times 1/2. When I multiply straight across, simplifying our answer is what gives us that final step of dividing. So that's how we get -3. And when I multiply 4 times 1/2, that's 4 times 1/2, or 4 divided by 2, which is obviously 2. Okay, so my scale factor is 1/2. So anytime you see the coordinates getting smaller in value, we're going to have a reduction and a scale factor that is a fraction. If our dilation is an enlargement, then we are multiplying by a whole number. Okay. Why don't you give this one a try? Okay. We have triangle ABC in black, and then we have triangle A prime, B prime, C prime. Count the length of BC and B prime, C prime, and determine the scale factor. Okay, so here we are. So first I'm going to count. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a length of 12 here. And B prime, C prime is 1, 2, 3, 4. Okay. So so BC is 12, B prime, C prime is 4. We have a reduction. We're getting smaller. And to write the scale factor, it's the image over the original. And when we reduce our fraction, both 4 and 12 are divisible by 4. So this is a reduction or a scale factor of 1/3. My red triangle is 1/3 smaller than my original triangle. And of course, same exact problem looking at the coordinates. We know it's 1/3 based on our previous, by counting the side lengths. But looking at my first, I got 9 to 3. So again, we're going smaller, which means we're dividing. Okay, and 9 divided by 3 is 3. 6 divided by 3 is 2. So 9 divided by 3 is 3. 6 divided by 3 is 2. -3 divided by 3 is -1. But we have to technically multiply when we're doing scale factor. So because we're getting smaller, we have a scale factor of 1/3, not a scale factor of 3.